The Chesapeake Bay and Pollution. The U.S. Environmental Protection Agency, EPA, defines point source pollution as any single identifiable source of pollution from which pollutants are discharged, such as a pipe, a ditch, a ship, or a factory smokestack. Factories and sewage treatment plants are two common types of point source pollution. Factories, including oil refineries, pulp and paper mills, and chemical, electronics, automobile manufacturers, typically discharge one or more pollutants into their discharge water, called effluents. Some factories discharge their effluents directly into a water body. Others treat it themselves before it's released, and still others send their waste to sewage treatment plants for treatment. Sewage treatment plants treat the human waste and send the treated effluent to a stream or a river. Non-point source pollution is the opposite of point source solution pollution, with pollutants released in a wide area. An example, picture a city street during a thunderstorm. As rainwater flows over asphalt, it washes away drops of oil that leak from car engines, particles of tie rubber, dog waste, and trash. The runoff goes into a storm sewer and ends up in a nearby river. Runoff is a major cause of non-point source pollution. It is a big problem in cities because of all of the hard surfaces, including streets and roofs. The amount of pollutants washed from a single city block might be small, but when you add up the miles and miles of pavement in a big city, you get a big problem. In rural areas, runoff can wash sediment from roads in a logged-over forest track. It can also carry acid from abandoned mines and flush pesticides and fertilizer from farm fields. All of this pollution is likely to wind up in streams, rivers, and lakes. Airborne pollutants are major contributors to acid rain. It forms in the atmosphere when sulfur dioxide and nitrogen oxides combine with water. Because acid rain results from the long-range movement of those pollutants from many factories and power plants, it is considered a non-point source pollution. Nutrient pollution is one of America's most widespread, costly, and challenging environmental problems, and it is caused by an excess in nitrogen and phosphorus in the air and water. Nitrogen and phosphorus are nutrients that are natural parts of the aquatic ecosystems. Nitrogen is also the most abundant element in the air we breathe. Nitrogen and phosphorus support the growth of algae and aquatic plants, which provide food and habitat for fish, shellfish, and smaller organisms that live in the water. But when too much nitrogen and phosphorus enter the environment, usually through a wide range of human activities, the air and water can become polluted. Nutrient pollution has impacted many streams, rivers, lakes, bays, and coastal waters for the past several decades, resulting in serious environmental and human health issues and impacting the community. Nitrogen occurs naturally in the soil, animal waste, plant material, and in the atmosphere. However, most of the nitrogen delivered to the bay comes from manure emissions and chemical fertilizers from farmland and animal operations, almost 45%. Nitrogen oxide emissions from sources including vehicles, industries, and electric utilities at 19%. Urban and suburban stormwater runoff, 17%. Wastewater treatment in factories, 16%. Septic systems that treat household wastewater and discharge effluent into the ground in the Bay watershed is 4%. Phosphorus, like nitrogen, occurs naturally in soil, animal waste, and plant materials, but these natural surfaces account for just 3% of the phosphorus loads to the Chesapeake Bay. Here are the major sources of the Bay's phosphorus pollution. The largest source is agriculture. Pause. The largest source is urban, suburban runoff and in-stream sediment. Agriculture and chemical fertilizer only account for 19%, unlike nitrogen. Agriculture manure, 26%, natural sources, 3%, and municipal and industrial wastewater is at 21%. Sediments are loose particles of clay, silt, and sand. When suspended in water, sediment can block sunlight from reaching underwater bay grasses. As sediment settles to the bottom of the bay and its rivers, it smothers bottom-dwelling animals, such as oysters. Sediment can also carry high concentrations of phosphorus and toxic chemicals. Most of the sediment on the bay comes from agriculture. Natural sources, stormwater, runoff, and erosion from streams make up the rest of the sources of sediment to the bay and its local waterways. Between 1985 and 2010, the duration of a dead zone fell from 5 months to 4, suggesting that efforts to maintain nutrient pollution through upgrades to wastewater treatment plants, cuts to vehicle and power plant emissions, and reductions in runoff when farmland are working. While rainfall and weather patterns affect the development of the dead zone, nutrient pollution is the foremost factor in its growth. When we look at these times between 1985 to 2017, both phosphorus and nitrogen decreased greatly in the bay. 2025 is a perspective. It's what they want it to look like. When nutrient-fueled algae blooms die and decompose, the resulting low oxygen conditions, known as dead zones, can suffocate underwater life and shrink available habitat. The dead zone is an area of little to no oxygen that forms when excess nutrients enter the water through polluted runoff and feed naturally occurring algae. This drives the growth of algae blooms, which eventually die and decompose, removing oxygen from the surrounding waters faster than it can be replenished in the process. This creates hypoxia, or low oxygen conditions, that can suffocate marine life and shrink the habitat available to fish, crabs, and other critters. Plant and animal life are often unable to survive this environment, which is why the area is referred to as a dead zone. The dead zone is most pronounced in the deep waters of the bay's main stem during warm summer months. So if you look at the difference in the amount of dead zone between 1988 in the summer to 2015 in the summer, it has decreased significantly. This was the bottom forecast for September 20th. And if you see here, there's a very small dead zone. So eutrophication, what is eutrophication? Eutrophication is what causes dead zones. So it occurs in 4 simple steps. Excess nutrients. So first, farmers apply fertilizer to the soil, Then excess nutrients run off from the field into the water. Fertilizer runs off from the field into the water. An algae bloom occurs. Boom, right there. The fertilizer, rich in nitrates and phosphates, spark the overgrowth of algae in body waters. Then we have oxygen depletion. When the algae forms, it blocks the sunlight from entering the water and uses up oxygen. Eventually, the water becomes oxygen depleted, and then algae dies. Finally, the water that is completely depleted of oxygen becomes a dead zone and can no longer support life. Over-fertilization. Basically, over-fertilization of water causes algae to grow on the surface. When the fertilizer enters the water, this becomes food for the algae. Because eutrophication stimulates algae growth, it's common to see a thick green bloom on the water. But the issue with algae is that it absorbs sunlight, preventing it from reaching the bottom. Especially blue-green algae, or cyanobacteria, can be very harmful to plants and humans. For example, it can be toxic if consumed. This type of algae is becoming a major environmental issue in most parts of the world. When algae grows to such an extreme level, it entirely stops light from reaching the plants in the water, and eventually plants that need sunlight cannot photosynthesize and die. As algae begins to form, it blocks sunlight from entering the bottom of ponds, lakes, and rivers. As more nutrients drain into the water, eutrophication repeats in a vicious algae bloom cycle and releases more nutrients into the water. When algae receive enough sunlight, they produce oxygen through photosynthesis and release it in the water. But without light, algae stop generating oxygen and consume it instead. When algae die, bacteria begin to decompose the remains, using up oxygen for respiration. Eventually, the decomposition causes the water to become depleted of oxygen. Over time, this causes the water to carry less oxygen than before. It can reach a certain point where fish cannot swim, and they suffocate to death in the water. Overall, a eutrophic lake can no longer support life. Finally, water without oxygen is anoxic and over time becomes a dead zone. When a water body reaches this point, it can no longer support fish and aquatic life like amphibians. Dead zones are more concentrated where we have industrialized nations, especially industrialized farming practices that contain nitrogen and phosphate or animal waste. In the northern Gulf of Mexico, adjacent to the Mississippi River, this is the largest hypoxic zone in the United States and the second largest worldwide. Eutrophication disturbs the aquatic life through nitrogen-enhanced fertilizer. Over time, this imbalance can cause aquatic life to start dying and, in the worst-case scenario, a complete dead zone.